Hello guys, welcome back to another video. In today's video I'm back with the part 22 for showing you the project that I done so far. And in the last part video I show you the two of the third of the project, and now in today's video I'm going to finish that project, and the project is face detection, and I'm going to continue from the past part video that we left on. So without further ado, let's get started. Okay guys, I'm back, and I think in the last part video we ended up here, and I promised to continue from this building the model, and now I'm going to do that. But I think yeah, here, right here, this is what we left on. So this from building the model is start from this code. So let's talk about this code here. Okay, what just we did it right here is we just going to build our model, our class model. So we do not use sequential. Instead of that we use model that can help us to create our texture of model that have their own class. So I'm going to show you that how it's done. But we imported model. We also import some layers here for layers input, conv 2D, dense, and global max pooling 2D. And then also we also import, and yeah, we also import some models that are trained already, but we are just going to import that. If you know, this VGG16 is a big trained data model that are free resource, and you can find it in TensorFlow. It is I think have more than 1000 classes that can classified inside of this VGG. But what we want to do in this project is we are going to change the last layer to be 2, maybe, yeah. Because we're using VGG16, because it have the model have some understanding of some those images. Maybe it's not related to the face, but it have some understanding for maybe the shape. I don't know, it have some understanding. So for that reason we just only train only for some parameter, and we are going to use some already trained model like this one, and we are going to just adjust this model that are already trained on other data. For that reason we are going to use VGG16, and here we imported SSI. I think, I don't know this one, why we did this. Maybe when we want to I think this will I think we download some HTTPS websites, some data. That's why I think we use this code. After we did that, we give the VGG16 to have variable of VG, and we also give some tuple include top to be false, and we also summarize the VGG. It will going to show us the layer, how much the VGG is have storage, and then also the trainable and the untrainable parameter it will going to show us. And here we build the model. We specify the building model function, and inside of this building model we have input layer to be input shape of 120 by 120 and by 3, and this is the shape of the input. This is basically the image of the shape. This third means this 3 is the color channel, and this is the shape of the image. Okay, and then here we say VGG to be VGG include top false, like this one here, and then also we pass the input layer, and we are going to do that for every single variable here. For example, for this one we pass the VGG, the second one we are going to pass the F1, like so on for other two. But here for F2 we are going to start with the VGG, and we are going to continue with F2, and the last one we are going to say regress one here. And if you ask this class and regress is different, it's because the class one is for classified if the face is appear in the frame or not. This is the model layer we are going to figure out. This regression layer we're going to figure out the point that the coordinate of those point to be where. So that's what we're going to figure out this regression layers. And at the end we say face tracker to be model, which is that we imported right here, and input to be input layer, this one, and output to be class 2 and regress 2 here, and we are going to return a face tracker for the feature model function. And I'm giving a detailed explanation because this is the most exciting part. That's why I did that, but I don't expect to do for every single code. And here we say face tracker to be this function, and we see the summary of the face detector model, and here we have x and y to be trained that as numpy iterator, and this will going to show us some random x train data, and we are going to plot it or see the shape whatever we want to see. So we just see the shape, and here we specify the class and the coordinate here by just predicting by putting the x, and we can see the coordinate in class if we run this one. And here I think we see the train length here and put for this variable, and then also we did some mathematical equation here and we give it for this variable, and optimizer to be Adam and with 0.0001 learning rate, and decay is not going to available in this version of TensorFlow, but I think that's why we use this mathematical formula. But it doesn't affect if whether we did decay or not, this optimizer. So here we also create our own localization laws, and this is for, I think, for the coordinate laws. And for class laws we use binary class tropy, and for regression we use this localization laws. We create this here, and we test it out here by just putting those prediction here. We taken here, and we also see the regression loss, and here we import gradient tips, and this help us to decrease the loss when you are building our model here. Okay, now we have the model, but to train it we have to have these types of class, and the classes looks like here. Okay, we say class to have face tracker, variable name, and we input model name, and we define int, and this can have some detailed explanation, but I'm just going to tell you what we did here. We just assemble everything that we did right here for only for one thing that we did, but instead of for one we just did for every single data. And here we just specify some variable here, and here we are training the data, and we specify the loss, also the total loss, and here the gradient type, and here also the test. This is for the validation data, and we are going to return this in text. We will going to print out this total loss, class loss, and regression loss. And finally we are going to code, and yeah, that's the training steps looks like, but we did not train it. We just create some functions, some classes for our training, and by specifying the model name and the function, the class name, we are going to train give the name for our training set, and we are going to compile it, which is we are going to specify the class loss name and the regression, and then also we are also specifying some boolean term here, running early to be true, and this is the log direction, which is the callback direction, and we are going to call back here, and here is where we are going to train the data. And we did for 14 epoch, and I'm just going too fast, but here we just see the history of the training set, and here basically we are just going to plot how the loss is increased and the accuracy of the training set is increased. And if we see some kind of weird plotting, we are going to maybe adjust something here, and we are going to okay, after we did that, we are going to test the model, how the model is performing by using this code. We are going to sample only one random data, and we are going to predict, and we are going to compare it with the real one. And here we saved the model, and we are going to load it, and here is the fun part is come to end. We are going to see how the model is working in real-time detection by using this code. This code basically will going to show, we will going to open the capture, and we are going to see the frame of the camera, and it will go to, if the model is good, it will going to make some rectangle, it will going to draw some rectangle on our face, and it will also classify it is the face. And yeah, that's all it's doing here. And we also have some if statement. If we press Q, or it will going to break this loop, and we are going to end up from that loop, this while loop. So yeah, this is this face detection project is looks like. And in the next part video, I'm going to continue from, I'm going to show you this fashion gain project. So I hope I see you there. Goodbye.